Lego room is not a classroom in the normal sense, it's a workshop where children can model the world that they live in using the Lego system, which is bricks, motors, gears, lamps and all sorts of things like that, plus a computer program that enables them to animate what they make. In this room, children work mainly in teams and not individually. So there's a certain amount of negotiation has to be done by the children as they work. They design and construct 4 whole school models each year, themed around autumn and Halloween, winter and Christmas, spring and Easter, and a summer fun fair, plus a small ski week model. There are 2 major foci in the Lego lessons. The first is to look very carefully at how their world is put together and how it works, and then model it using Lego elements and Logo computer coding. The second one is to apply the knowledge from mathematics, science and coding that they've learned in their other lessons. The other thing we do is to make sure that our Lego is up to date, and to do that we make special Lego pieces ourselves. We've recently been making LED lamps, which means we can talk about electrons, photons, and we have 2 little fairies. One is Ellie the electron and one is Freddy the photon, who help explain electricity and light to very small children. Coding in the Lego language enhances the English learning and takes mathematics and science beyond the normal curriculum. Normally, playing with a Lego set involves reading the set of instructions and following them, and then later doing your own thing with the little bits that you use when you dismantle it. Here, we learn how to build from scratch. We learn the basic principles of building, and then the children design and build their own things using sound construction methods. But what is play? We play chess. We play with ideas. So Lego classes are not only just about learning the rules of sound and attractive construction and then applying them to practical projects, but there is an element of creativity and play that is an integral part of it. Most children in the primary school age, which we work with, are naturally curious, and so we build on this. The part that does need motivation is the teamwork, because small children need motivating to work together, to negotiate and work out the leader-follower relationships. And in teams we encourage them to exercise their individual talents. In these lessons we have to remember that the primary school children we teach have got brains that are maturing particularly quickly over that age range. So we have to make sure that what we ask them to do is correct for their level of maturity. And of course the speed varies from child to child, so we have to make sure that each individual child expresses their abilities to the best they can. One thing we do is to ask children to draw the models they've made, so we get an idea of what their thinking is like in terms of how they see the world and how they see the models they've built. And it's very interesting because they don't see the models, they don't see them properly, they interpret them and put them down in their standard normal children drawing style. I will get them to do a design beforehand, but not as a regular thing. What I'm interested in is the design afterwards, their ability to look at what they've made and represent it, and they never represent it as they see it. Our Lego Logo curriculum is built around the English design and technology curriculum, so that is what tells us where the emphasis should be. But really our world is as it is because we developed a whole range of technologies. Now many of the things we use every day have computers inside them. We have a special name for them. They're called Turing Machines because we have a hero in Alan Turing. And by modelling carefully selected parts of the everyday world using sensors for touch, temperature, light and motion, and LED lamps, motors and sounders, we introduce the foundations of computer control and robotics. Remember, not all robots run around. A lot of them are static.
It's becoming more and more an evidence that robots will take a huge role in our future. Robotics program uses a special robotics platform which includes and learn the 4 STEM subjects. STEM subjects are science, technology, maths and engineering. Students used to apply maths and science in the technology and in robotics rather than not understanding why they are taught in school. Essentially, a robot is a mechanical device that can be programmed to follow and see instructions. Programming can be too abstract sometimes. By having to control a physical robot and seeing what goes wrong, students learn what robots can and cannot do. Robotics can be defined as a science of study of the technology associated with design, building, construction, a lot of programming and a lot of theory. At the end we have a final magical product. So crafters and researchers in robotics study more than just robotics. It's something innovative and almost everything around us is surrounded of technology and robots. Using them in medicine, in transportation, space or everywhere, they can improve our quality of life. Students can develop and design their own robots and they almost always have something to solve, like a real problem in their life. Every time they have fun. Sometimes they know that they have to learn a lot of theory, but after that they know that we will have their playing and curious time to play with the robots. In our British School of Sofia, I'm very proud that we have 2 different sets of robots. One of them is Lego Mindstorm, EV3 Lego Mindstorm, and the other is Vex IQ. The similarities between them is that we have a lot of programming, but EV3 has a lot of building and constructions inside, and Vex Robotics have its own remote control, and children have real fun remoting and driving the robots in such an easy way, because the programming is very hard in our subject.